Dear learners, happy learning.
Okay, today we are going to see about your Part-3 session of Chapter-2, that is number system. So we will make a small recap of Part-2 session. What are the things we gone through? We saw various conversion, number system conversion, right? So what are the things we saw? Fractional, decimal to binary we saw. What are the steps involved in that? Then binary to decimal conversion. Binary, under that binary we will have three main category: binary to decimal, binary to octal, and binary to hexadecimal. Okay, next one is conversion of fractional binary to decimal. Okay, next we learn about octal to decimal, octal to binary, two condition, then hexadecimal to decimal and hexadecimal to binary. So this is your part 2 session. All conversions we saw with example, right? So now we will see the learning objectives of today's session. So today we are going to see what is binary representation for your sign number. Okay, next, what is binary arithmetic? Arithmetic, you all know what is arithmetic. Arithmetic operation, what are the different arithmetic operation ma? Yes, plus, addition, subtraction, multiplication and division, right? So here we are going to learn about binary addition and subtraction. Okay, so that one. So under this 2.5 and 2.6 we are going to learn about what is meant by sign magnitude representation. Okay, ones complement representation, twos complement representation. Under this binary arithmetic we are going to see one is binary addition, another one is binary subtraction. Okay, next, representing characters in memory. How you are going to represent your characters? So character means alphabetical things. Okay, how you are going to represent these characters in the memory of the computer? Under that we are going to see about the encoding concept. Encoding means what is your original code? If you are going to rearrange that code, that is called encoding. Okay, so how you are going, then ASCII code, Unicode. Okay, then ISCII. So these are all the things for representing characters in memory. So we will see briefly what are the things. BCD. BCD stands for binary coded decimal. Okay, then EBCDIC. It stands for extended binary coded interchange code. Okay, I means interchange, C means code. Then ASCII. So ASCII means American Standard Code for information interchange. And coming to Unicode, Unicode you may have or hexadecimal schema for various languages like Tamil, Malayalam, Telugu, Kannada and so on. Okay, next one, ISCII, Indian Standard Code for information interchange. So these are all the various coding part, representation of character in your memory. Okay students, okay, let us see one by one deeply so that you can able to understand well. Okay, so first we'll see about what is binary representation of your sign number. So how will you represent your binary number? No, so computer can handle both positive. Positive means that is called as signed. So that is called as sign number, as well as negative numbers. Simplest method, no, for representing the negative binary number, no, that is called as sign magnitude. Similarly, your here in the sign magnitude, you will have leftmost bit and rightmost bit like that. So this leftmost bit is called as MSB, most significant bit. Similarly, rightmost bit is called as least significant bit. So this MSB is called as signed bit or parity bit. There are a number of representation in your computer by various type for signed magnitude representation. How you are going to represent the signed magnitude? No, so signed, by hearing the name itself, you have to very clear in your mind what is meant by signed ma. So plus is one sign, minus is one sign. This is the two sign in your number system, plus and minus. So positive and negative, that should be represented by using this plus and minus, right? Then sign magnitude representation for one's complement and two's complement. We will see what is one's complement and what is two's complement. Yeah. So this is the binary representation for your sign number. So what are the things you have to keep it in your mind? First thing is it should be your positive unsigned number, then your negative number. Negative number means that is signed number. Then the simplest method to represent negative number is using your signed bit. That should be least significant bit value. That value will be in right side, and most leftmost bit is known as most significant bit, that is called MSB. It indicates your signed bit or parity bit. I will show you the representation, so only you can able to know the concept very well. I will show you the picture of this MSB and LSB. Similarly, sign magnitude representation, you have to come across the concept of one's complements and two's complement. Now, see this example. Here, you are having plus 43, okay, or 43. Both are same. Plus 43 and 43 are same. If you indicate with sign, plus means that is positive number. If you doesn't indicate anything, means that also positive number. Negative number should be followed by what ma? Minus 43. So minus 43 means it indicates your negative number value. Now see this part here, the sign no, it should be in leftmost. Okay, so here the sign is represented as minus. This is called sign bit. If the bit is 0, it is positive number. If it is 1, it is negative number. This one you have to keep it in your mind. 0 and 1. 0 means positive and 1 means negative. Therefore, sign bit no, it has 8 bits totally. Only 7 bit used for storing values. Those values are called as magnitude. And 1 bit no, totally 8 bit. So 7 you are going to store the value, and the remaining one no, it indicates the sign, which sign the number is, whether it is positive or negative, like that. So positive means what sign will come? It should be represented with 0. If it is 1, it is negative number. Clear ma? So one thing you have to keep it in your mind for representing your sign magnitude representation is, if the number is positive, it will be denoted with plus or round of that number. If it is negative means minus sign will be given to it. Now see this example. This is the magnitude value of plus 43. Okay. So based upon the code no, we used to write in that code, it is the value, that is your binary representation. 43 divided by 2, like that if you keep means this is the value. So totally I told you how many characters, how many bits are 8 bits. Now calculate. 0 is 1, again one more 0, 2, then 1, next 1, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8. So totally 8. 7 will use to indicate your value, and 1 is your sign bit. So the 0 is your sign bit. These are all the magnitude value of 43, and this is least significant bit, LSB. And here the leftmost is most significant. It is represented with 0. So it indicates 43 is your plus number. Now coming to the same example. So I am giving the value for 43. Here the magnitude of the value is specified in this 7 bit. In MSB no, I am indicated with 1. So 1 represent what ma? It is negative. Okay, I told you no before. So 0 means positive. So see, 0 means positive and 1 means negative. The same thing here we are showing. Here the MSB value is 0, so it is plus 43. Here the MSB value is 1, and it is minus 43. Now we will see about what is one's complement representation. Okay, so first take down, you are having steps. What are the steps to be followed for writing your one's complement representation? So step 1 is convert the given decimal into binary. That is your first step. Okay, after converting your number to binary, what is your second step means you have to check the number binary, it contain 8 bits or not. If it is less than 8 bit, in leftmost part you can add a value of zeros, because if you add rightmost value 0 means what will happen, the value will change. For example, you are having 10 rupees. Okay, how will you write 1 0? If you add one more 0 to the right side, 1 0 0 means it will become 100. Before, if you add 0 means 0 1 0, so nothing will happen, so 10 is the value. So that is your second step. Now consider this example, writing for 24. First thing is convert the given number into decimal, into binary. I am going to change the binary value of this. So how we are going to change? Check it off. So 24, no, here. Okay, you are dividing by 2. So 12 2s are 24, balance is 0. Then again 2. So 6 2s are 12, balance is 0. Again by 2. 2 3s are 6, balance is 0. 2 into 1 2, balance is 1. So how you have to write now for this coding output? Like this indication you have to write it off. Okay, from down to up, this is the indication. So 1 will come first, again 1, then 0, 0, then 0. So what is the conversion? Decimal to binary. So this is 10. 10 is decimal. So you have to change to binary. So bracket of, then write 2. 2 is the binary representation. Radix value for binary is what, ma? In first video itself we saw in this chapter 2. So what is the representation for decimal? It is 10. For binary it is 2. This is the radix value. We have to keep down. Clear? Okay. Next we will see, after this conversion, this whole value, no, it should be represented, the given decimal, into your binary value. So next is check if the binary number contain 8 bit. If it is less means you have to add 0. I told you, no. So here what you have to do is you have to check the value of it. Okay, you just check the value. Yes, I'm going to check it off. How many values? Just to count 1 1 0 0 0. So totally 2 and 3, 5 only is there. So what you have to add, ma? You have to add 3 digit more. So that should be represented by right side or left side? Left side. Okay, if you add right side means, this is for example you take 1 1 0 0. So it may be 11,000, right? So if you add one more 0 next to this part, means what will happen? It become 1,10,000, right? So like that it will be changed off. So what you have to do is you may have the zeros before to it. Okay, that is the step. Okay, next thing is, what is, you have to, after representing your part, that is you have to take one's complement. One's complement is what is, that is your third step. Invert all bits, that is change 1 as 0 and 0 as 1. Here 0, change 1 1 1 0 0 1 1 1. So this is the value for your 24, minus 24. Okay, so minus 24 to the base 10. We have converted that one into decimal to binary value, and how to take one's complement for it. So one's complement means you have to invert all the bit. Okay, now moving to 2's complement, we will see how the 2's complement representation works off. So now in this example, the same thing, just to follow the steps. 2's complement method, no, for negative number is as follows. How, no, you have to invert all the bit in the binary sequence, change every 0 to 1 and every 1 to 0. That is 1's complement. After that, what you have to do, no, in 2's complement, you have to take first 1's complement, then add 1 to the result of your least significant bit, that is your LSB. Okay, so in the LSB part, you have to add 1. The same example you take, this 24, I am taking and converting to binary equivalent for decimal 24. So 11000. So what you have to do is, first write it off. You have to make compensation 30 to make it as 8 bits. Then takes 1's complement 111001111. Okay, you have to write from right side to left side. Then what you have to do? This is the step, no, adding 1 to your result. So what you have to do, no, you have to add 1 at the end of the bit. So we will see how we are going to add and what is the result of that. So that should be added in your least significant bit, that is right side, this one. In this one you are going to add 1. So add 1 to LSB. So that is the step. So I am going to add 1 and write the output of this. 1 means it should be 0, because 1 means it should be act as here everything or machine language. So 1 means it indicates 10 like that. So 0 will be come down. After that 1 will get carry over. So you have to keep 1 more. So 1 plus 1 again 10 like that. So 0 you have to write in this. Again you have to make a carry over. So I am writing 0 here and making a carry over. Again 1 it indicates 0 here, carry over. Only 1 plus 0 is 1. Again 0, 1, 1, 1. So you can check minus 24 means what you have to check, the most significant bit. This MSB value should be 1. It is 1. Okay. So automatically you calculated and change the value to 2's complement. This is the 2's complement of minus 24. Here. Okay, ma. Now we will see about binary arithmetic. Under that, binary addition. So binary means what? It should be value of zeros and 1, right? So I am having the value of 1011. You have to make a representation in the code format. What is your code, ma? 8421 code. Okay, this is the representation. I taught you already. So take down and write that one. Then write the proper conversion where you want to make this addition part. So binary arithmetic means the binary number also permute your computation like addition, subtraction, multiplication and division. In this session we are going to deal only with binary addition and subtraction. Okay. So in this addition, no, what are the things you have to keep it in your mind is, if the value for two numbers, one number is 0, another number is 0, the sum will be 0 only. Okay, let us see this table. So 0 0 means it will be 0. So 0 1 means answer will be 1. 1 0 means 1. 1 1 means it should be 0. Okay, I already told you 1 1 means it should be represent like 10 1 0. So 0 you can keep here and carry you have to keep 1. So 1 1 means it should be the value, what the value will represent, no, that should be 0 and you have to make a carry part of 1. So 1 1 means 10. I told you just now. So that particular 0 as sum and 1 as carry, you have to take it off. Clear, ma? Okay. Now this carry bit, no, it will be added with the previous position of the bit pattern. So where you want to add means the previous position of your bit pattern, it will get added. Again 1 is there, it will be added along this 1 together. That also make a value of 10. So 0 will come down, 1 will goes up. Now see this based on this concept. Take down this example, 1011 plus 1001. So this is your question I'm going to make addition, binary addition. So what is the value will come for this 1 1? So 1 1 means it should be 0. Carry will be 1. Next 1 1, so will be 0. Again carry will be 1. So 1 plus 0. What will be the output for this? That should be 1. Okay. So based upon that example, you have to write it off. So that value will be represented 1 here, then 1 1. So finally it will become 1 0 because there is no other digits to make a carryover. So represent the 1 after to 0. So 1 0 1 0 0. This is the answer for your value of 1 0 1 1 to the base 2 plus 1 0 0 1 to the base 2. Clear? So this is the answer for this. Now we'll see about binary addition for adding 23 to the base 10 and 12 to the base 10. So first we have to make a conversion table for calculating the value of 23. So this is decimal equivalent. So what you have to do? You have to change it to binary equivalent. So just divide it off by 2. So after this you may get the value of 1 0 1 1 1. Okay. So from down to up, I already explained to you. The same thing you have to follow here. Similarly write for 12 also. So 1 1 0 0 to the base 2. That's all. Then you have to write the yes. After this you just write the that should be in 8-bit manner. No, you have to represent the remaining data as 0. I am representing it as 0 here for this table 23 value. Similarly write for 12 also. Okay, I am writing for this 12 also. Yeah. Okay. Next this is the table we already saw, no, for summing the value. So 0 0 0 0 1 1 1 0 1 1 1 0 and carry will be 1. Same thing 1 1 10 0 1 again 0 1 0 0. So this will be the output and the value should be represented with base 2 because this is binary. Okay. So after decimal is there, you have to convert the decimal to binary and have to make your addition part. So this is the binary arithmetic for binary addition. Clear? Okay. Next we will saw about binary subtraction. Same logic, but consider this table. What is the value for binary subtraction? So both 0 means output will be 0. Okay. 1 0 means output will be 1. 1 1 means output will be 0. So 0 1 means output will be 1 as well as it will have borrow. In some part if it is more means you will have carry, no. Similarly here what will happen, no, if it is less 0, from 0 you cannot able to subtract this 1. So you have to borrow 1 for this. Okay. So what will be the value of 0 and 1? It should be the value of 0, but this 1 represent borrows. So 1 is borrow, answer is 0. Now compare this one 0 0 0 1 0 1 0 1. What you have to write? You have to borrow 1 from this. So this 1 will goes here 1 1. 1 1 means answer will be what? 0. So here what will happen? It will gives 1 means it will become 0. It will become 0. So what will happen is this 1 will come as 10. So 10 means that 1 here. This should be 0. So 0 minus 0. In this stage also will leave the output 0. Here 1 1 will be there. So that 1 1 output will be what? It should be leaves a value of 1 and so here 0 point is 0 0 by 1. You can't able to take, so you have to borrow. That also 0. So what you have to do is you have to shift this 1 to here. So it become 1 0. That column, no, last column, that is your 7th place. Yes, it is your 7th place. It will become 0 there, and your 6th place it will become 1 0, but it will not use that. You have to give borrow to the next value. Okay, so I am giving borrow to the next value here. So now it become 1 0. So 1 0 you are going to subtract it off. So you are giving borrow and get subtracting it off. So what will be the difference value will be 1. Okay, so in this case here it will return the output as 1 here. Okay, okay ma. So it will return the output as 1. I will show you. So what is happening? Now listen. Yeah. After this is giving the value here, no? So that value will remain as carry over 1. So that is 1 and rest is 0. Now coming to binary addition of 21 to the base 10 plus 5 base 10. You just make this one as your assignment part and do. Here you may represent this using your 2's complement value. This is one way of representing. You just see how it is represented. So 21. So I am representing the one value. This is your calculation for giving your 21. We saw no already decimal to binary. Same thing you apply. So the output will be 10101. So it is only 5 digits. The rest is the things you can apply for 0. So 000100101. I am writing this one as an output. Then what is the thing is you have to do is you have to make your 2's complement, 1's complement. So whenever is 1 it is 0, whenever is 0 you have to write 1. So 0 1 0 1 0 1 1 1. Okay, next thing is you are going to add 1 at your least significant bit value. I am adding 1. So what is the value? 1 1 1 1 1 0 0, again 1 0 1 0 1 0. That is your what the value is, you are just copying the value, only adding this 1 at the LSB. So the final answer will be 1110111, and the indication is minus. Then you have to check it off, that is your MSB value is 1. So automatically if it is minus means the value will get 1. If it is when only 21 means that is plus value, means what the parity bit indicate, that sign bit indicate the value of 0. Yeah. Now take down for 5. Represent this 5 in decimal part. Okay. Okay ma. Just to represent the value for 5, find the decimal equivalent of this. After that what you have to do, you have to make the both things, you have to make and get added off. I am adding this binary equivalent value for 21 base 10 plus 5 to the base 10. Okay, so I am adding this one. Let's take down the output of this. It should be, what will be the value? 1 1 means 10. So 0 1. So that 1 1 means again 0 1. Again 1 1 means it should become 10. So 0 1. And to the next stage it will move to the value of 1 is that, again you are going to add 1. So that value also indicate the value of 10. So again 0 1 In that part only 1 is there, in down you are having 0, so 1 0 is what the value? 1. Next 1 0 is 1, again 1, and last also 1. Okay, so this is the output for adding minus 21 to the base 10 plus 5 to the base 10. So minus 21 only is there, so only we are taking this 1's complement and 2's complement. Here this 5 to the base 10, there is no change in this, so we are writing the binary representation of this decimal part alone. Okay, after that we are adding this to binary additions. Clear ma? Okay. So next part we are going to see about your encoding part. So this is the last part in this session. Under that you are having 5 main concepts we discussed. Okay, we'll see what is BCD. It is binary coded decimal, I told you. So in this part, this representation, no, here all the inputs data given to your computer should be the machine understandable part. What the machine will understand? It will understand the value as zeros and ones, whatever the human may give, but the machine will, computer will take it as zeros and ones. Okay, that should be read by your machine. So that value to be executed in which format and all, no, in generally you will have 26 uppercase letter, similarly 26 lowercase letter. Coming to digit you will have 0 to 9 and special character. These are all altogether called as character sets. Okay, so this character set implies all the character sets denoting through your number only, because the machine understand all the things in your binary format. So I am specifying all the things here in number. So first I am specifying BCD is binary coded decimal. EBCDIC is extended binary coded decimal interchange code. Then ASCII code, American Standard Code for information interchange, Unicode, as well as ISCII, Indian Standard Code for information interchange. We will see one by one what is the use of each code and what is the main difference between this code. First, coming to BCD, this code, no, it is not in practice now, but its representation should be, encoding system will be 2 power 6, that is if we can handle only 64 characters alone. So that is BCD, that is your binary code. So we saw this BCD representation in decimal part. If the decimal is 0 means binary value you have to write using 8421. Similarly here decimal value means you have to represent the indication part of this. Okay, next the binary representation equivalent to 5, that also will be 8421. Now coming to ASCII code, this code stands for American Standard Code for information interchange, and this code is recognized by United States. So only the code is called as American Standard Code for information interchange, and most of the computer know using this code, that is ASCII code. Okay, so whatever the A, you will specify A means it will have some one value for A, that is your ASCII value. So if you specify A means automatically the system will takes only your ASCII code. So it can handle 2 power 7 bits, which mean 128 character. BCD handle, no, how many characters we saw BCD? 2 power 6, that is 64 character. And this ASCII code, no, it will handle 2 power 7, that is 128 characters it may handle of. So in this system each character has individual numbers. I will show you your reference table based upon this all the codes after explaining the concept to you. Okay ma? Okay. Next this individual numbers, no, it will handle a new version of ASCII 8, no, it will handle 2 power 8 bits. So totally it can handle 256 characters. So the character value will be ranges from 0 to 255. Okay. That is your unique number value. For example, A is one character, its ASCII value is 65. It may vary for your capital and small number too. Similarly, the binary representation ASCII bit is value is, that is your 7-bit formation. Okay, so also you can represent, before you are representing 1 0 for converting to 8-bit, no, that also indicate your ASCII 8-bit value. So these are all the chart representation for ASCII value of your code. At symbol, no, that symbol will have a value of 64. Similarly, capital A 65, small a 97, like that it will be goes on. So this is the table where the alphabet, number, bit conversion, ASCII code representation value, everything should be listed here. It is available in your book also. You just go through it. No need to memorize this one. You just go through what are all the codes available, like that. So you will have alphabet, what is the number equivalent to your alphabet, 8-bit conversion. Okay, next octal conversion. For the same code you will have hexadecimal conversion and all. Similarly, for special symbols, you can represent this code for special symbols also. Now coming to extended binary code decimal interchange code, it is more or less similar to your ASCII code with 8-bit. Okay, so it is developed by IBM, that is International Business Machine. This code is generated. In ASCII code is generated by US, okay, America. This code, no, it will handle 256 character. ASCII can be converted to EBCDIC system, and EBCDIC system can convert it to ASCII. Vice versa, you can change. So this is ASCII versus EBCDIC. Just to make a note of it. Here ASCII means it character encoding standard for electronic communication. Similarly, here 8-bit character encoding used on IBM mainframe and IBM mid-range computer operating system. Similarly, ASCII, no, it stands for American Standard Code for Information. This is the difference between these two. Here it stands for Extended Binary Code Decimal Interchange Code. In ASCII you can use 7 bits. Similarly, EBCDIC you can use 8 bits. It represents 128 character. Here it represents 256 character. All the characters are in consecutive order in ASCII, whereas here you will have 9 characters at a time, group of 9 characters. It is compatible with modern encoding such as Unicode. It is not compatible with your Unicode. ASCII is more efficient, whereas your EBCDIC is less efficient use. Okay. Next, this is the ASCII representation code for various languages like Bengali, Tamil, Telugu, Kannada, everything. 8-bit coding, therefore it can handle 256 character. So this ISCI, this code is recognized by Bureau of Indian Standard, that is BIS, the year of 1986 to 88, under the Department of Electronics in India. Okay, now this coding system is integrated with Unicode. This code is integrated with Unicode concept. Next, coming to Unicode, it is universal code. Here you will have 16-bit code and handle 65,536 characters. This Unicode can handle this much characters. So Unicode schema is denoted by hexadecimal numbers too. So this is the Unicode table for Tamil, and this one for Malayalam, and this table for Telugu, and this is the table for Kannada. Okay, just to make a clear view of this. So you may have Unicode because it is universal code with various languages. Okay, ma. Okay, up to this we will end our chapter 2. Now coming to the summary of the session, what are the things we gone through? We saw about binary representation for sign number, then binary arithmetic. Under that we saw about sign magnitude representation, that is positive or negative sign. Along with that we gone through what is ones complement, two's complement. Now, coming to binary arithmetic, you will have binary addition and binary subtraction method. And next we saw about characters in memory, how to represent characters in memory. Under that, we saw about BCD, EBCDIC, ASCII, Unicode, and ISCII. Okay, now take down the home assignment for this part. 2-mark question, list the encoding system that represent character in memory. Next question, write short note on ISCII. Add 22 base 10 plus 15 base 10. This 22 is minus 22. Similarly, 20 base 10 plus 25 base 10. So 3-mark question. Next, find one's complement and two's complement for the following decimal number. So what you have to do, you have to convert this decimal number to your binary equivalent first. Then you have to make one's complement. Then you have to make your two's complement. Yeah. Okay. Once again, you go through this video so that you can make a reference and solve this problem what I given as your home assignment. Okay, student. Okay. Now we will see the evaluation of this chapter. So coming to this evaluation, first question, which refers to the number of bits processed by a computer CPU. The number of bit processed, that should be calculated by using what? Word length. Next, how many bytes does 1 kilobyte contain? So 1 kilobyte means 1024. Okay, 1024 bytes. Expansion of ASCII, American Standard Code for Information Interchange. That is ASCII code. 2 power 50, 50. What is sigma? Penta. 5 means penta. Okay. How many characters can be handled in binary coded decimal system? 64. Okay, 64 character. For 1101 base 2, the equivalent hexadecimal value is what? So this value you have to convert to 8421 code. 8421. So 8 value is 1, 4 value is 1, 2 is 0, last is 1. So 12 plus 1, 13 is the answer. So in hexadecimal, the value of 13 is up to 9 is the value, 10 is A, 11 B, 12 C, and 13 is D. So answer is D here. Okay. So next question, what is the ones complement of the value? So 7th question, what is the ones complement of 0, 0, 1, 0, 0, 1, 1, 0? So ones complement means you have to reverse the bits. So 0, 0 means you have to write 1, 1. 1 means 0, 0, 0. So 1, 1, 1, 0. So 0 is 1. So answer will become B. Which amongst? This one is not an octal number. So octal number conversion is 4 to 1 code. You have to convert and check. So answer will be 876. This number will not be an octal number. Okay. Okay, students. Hope you all understand the class well. Let us make find an answer for your puzzle that we discussed in last session. Can you able to remember what is the puzzle we gone? In last session I gave you one puzzle. Yes, breeze into cyclone, drizzle tends to what? So breeze means it is the wind. Okay, mild wind is called as breeze. So if the wind is heavy, then it is called as cyclone. Similarly, drizzle means droplets. Okay, droplet of water is called as drizzle. If the water drops will be in more means that is called as downpour. What ma? Downpour. Okay, so the answer is B. So B is more intense than the first. So here cyclone is more intense than the breeze. Similarly, downpour is more intense than the drizzle. Okay. Okay, student. Now take down today's logic question. Coming to today's question. Same concept like this. You have to find the correct alternative. Errata stands for books. Similarly, flaws. What is meant by flaws? Okay, student. Find the answer for this. We will meet in your next session. Okay. Thank you.